Starship, Flight Test 5, and what's coming after that?
Kind of old news. I'll kind of skip through the highlights and talk more about what's coming. I'll show you a series of pictures taken from the live beta display. If you watched it while it happened, you would see this, or it's available online. Obviously, it took off, and that was about a month ago. This is as it gets started. And it's a time machine. Now, suddenly, we're at the point where the booster is landing. And this, of course, is the signature move of this particular test. No one's ever done anything like this before, especially with something so big. So they did manage to land the booster right in the so-called chopsticks, the landing tower there. That pretty much amazed everybody. This is a view at the top after it was done landing. You can see the grid fins there. That's not what's supporting it. There's actually just little pins sticking out the side. Those are the grid fins, which are aerodynamic surfaces for controlling the direction that it falls. But the actual pins are just kind of the little tiny things sticking out. And it's amazing. It's supporting all that weight. Now, meanwhile, of course, the second stage was still going up. And at this point, it was already coasting. You can tell that because on the right-hand side here, they're showing you which engines are lit. And no engines were lit at that point. There's 6 engines on the second stage. It's just coasting. So that red and various colors you see there, that's plasma. It's just because it's getting so hot. It goes up, it's kind of a ballistic trajectory in effect. It's just coasting and coming back down. This is right before it landed. They hadn't actually quite turned the engines on. It looks like they were just lighting them up, and the display down here just hadn't updated yet. Only the very last minute, they really do just a few seconds before landing, they suddenly flip around and put it down, and they landed vertically in the ocean. And then it finally tipped over, and there was still some fuel, so it made a nice explosion and burning kind of effect there. So very dramatic. Of course, they had buoys sitting there. They landed exactly where they wanted to, and right in between the buoys that could take all these pictures. So what kind of results did they get from this? Well, the first thing is that compared to the last test, it did much better because they had a much better thermal protection system. They had done a couple of things. First of all, they put better tiles in. I guess they were thicker or better materials. But also underneath the tiles, they put in a whole new layer of ablative material, stuff that will burn up. So even if the tile falls off, and sometimes tiles are going to fall off, they get knocked off or turbulence tears them away, whatever it is, in any case, they have a more protection underneath now, and that made a big difference. And also, in particular, last time, they managed to land pretty much where they wanted to, but some of the control fins were in pretty bad shape. They pretty much burned through, and it was amazing the control system was good enough that it landed anyway. But they put a lot more protection in for those, and they held up much better. They still have a ways to go. It did actually burn through in a few places, but it was really pretty good. Of course, the big thing was the so-called chopsticks that just caught the booster. Now, people kind of assume that the thing is coming really fast and it's just going to grab it and absorb a lot of the shock. Actually, it's going really, really slowly at that point. It's just under power, and so it really just has to gently grab it. The booster is almost hovering. Actually, that's something the Falcon 9 can't do. They have more power available. With the Falcon 9, when they land, those legs are absorbing all that shock. The reason they're doing this, catching the booster in midair, is you don't need to have landing legs at all. Now, obviously, later on, when you're going to land on the moon or Mars, you're going to have landing legs. And maybe even if you're going somewhere else on Earth, you might need that. But for their routine flights, they want to have the thing go out and have the first stage come back to the original landing site. And basically, you take the complexity and the weight and just shift all that. Instead of being on the booster, it's just back on the facility. So that's why they call this stage 0. The launch tower is a significant piece of the overall system. It's not just a rocket, it's a whole system. There's another benefit to having the booster being caught by the chopsticks, and that's that you got it right back where you want it because your refurbishing facilities are right there. And maybe in the future, they won't need much refurbishing. They could even maybe do it on that launch pad. That's the dream. How long it takes to get there, we don't know, but that's the basic goal. They need to do this because otherwise it takes a long time to get the booster back, bringing it back into port and then transporting it on land, wherever it has to go. That takes time. And that's going to matter because they want to launch a lot, and they have to launch a lot because the really long-range missions to Mars or even to the moon requires refueling in orbit, which means you got to have a lot of Starships going up there carrying a load of fuel to refuel the one that's finally going on to the moon or Mars. So it really matters. Nobody really knows yet. They don't know the payloads. They don't really know how many flights it will take, but estimates range anywhere from 8 to 16 to get one deep space kind of a mission. So they need to be able to quickly refurbish these things, or they have to have a whole lot of them out there in transit between landing sites and the original launch site. Another obvious conclusion, I worked in control systems for a while, and these people really understand how to control things. I mean, they've got a really complicated system here. They go from incredibly heavy to almost empty because the fuel goes away. They have different levels of gravity, different levels of control, either from the aerodynamics of when you're in the lower atmosphere compared to almost no air up near the top of the trajectory. There are so many variables there that they have to deal with, and they're doing an amazing job. So I think they're kind of the unsung heroes in this thing. They did have minor damage. As I mentioned, there was some burn through. Some of those flaps did get a little bit burned up. They still have to work on improving the heat resistance there. Now, there's a thing called a chine, which is really just a long fin, kind of a small fin that goes down the back of the booster down toward the bottom, typically to help control airflow. Some of the covering for that actually ripped off in the process. And that happened apparently just on the way back as they were going subsonic. And apparently the shock waves associated with that transition tore it up. That was potentially disastrous because they have some valves in there which are needed to control the flows for the landing. So it all worked. The valves were unharmed, but obviously they're going to work on that to make sure that doesn't happen again. There was some question about the engines on the booster. There may have been some damage. People thought they saw some pieces of stuff flying off near the end there. So it remains to be seen. You do see a certain amount of smoke and debris. Sometimes that's just the thermal protection stuff burning off. The other thing is that we found out inadvertently that they were pretty close to aborting the whole thing near the end. Basically, it was because of a false alarm, which they concluded was really not a software error, but a parameter error. Some large number of criteria for, is it okay to do this landing back at the launch site? And one of them wasn't really set right, and they came pretty close to violating that one. It would have been a false alarm, but then they would have had to abandon the mission. So, Test Site 6, that's the next one. It might happen around November 18th. And part of the reason is, well, one, there were no major changes in the flight plan, so that the current license applies for that. And the second thing is there were no major abnormalities that happened in this. It was a good flight, so there's nothing that has to be investigated to hold up things. So they're going to be doing this next one pretty soon. Obviously, they're going to do what they can to address some of these minor damage issues and revise those parameters. A key part of this next test, most people think, is going to be relighting the second stage engines. Now, remember I said that in this test, the booster goes back to the landing site. The second stage goes on up, and it's just kind of coasting after it does its burn. It's just coasting and coming back down. Well, they have to test lighting the engines in space conditions. They know it works down lower because they turned on the engines when you're back in the heavy atmosphere right before you hit the ocean. But they haven't done it in space. That's important because if they're going to have a next test, which will involve orbiting, and in particular orbiting and then transferring fuel from one vessel to another, they need to be able to then have good control over how to deorbit. And that says you have to be able to relight your engines. Nobody thinks that's necessarily a serious issue. That's why they haven't worked it so far. But it's still something that has to be proven. They haven't actually relit that engine in space yet. So that's a big part of this coming test. Then, of course, thermal protection. Some of that thermal protection changes are coming from moving the flap back a little further from the front. That's already in the works. It's probably already done on some of the manufactured second stages. I'm not sure where that stands, but at some point that comes in. Next thing, though, is going ahead to low Earth orbit. Once they've established they can relight the engines, it will be safe to start doing orbital tests. Nobody thinks that's going to be a serious problem because the speed they're going now is almost achieving orbital velocity anyway. That's why they purposely wanted to get it up there going as fast as possible without going into orbit, just for that reason. Next thing is there's a second launch tower being constructed down at Boca Chica. That has to be finished, tested out. It is stage 0. It has to work just like the other one. And the big thing coming up, not in the next immediate mission, but sometime in 2025, they really want to start doing the propellant transfer while in orbit. Now that means you have to have 2 of those up there. And they're talking about maybe launching them 3 or 4 weeks apart. But even doing that, you probably want to have both of those towers in operation. So I'm not sure how that's going to work. NASA was pushing very hard. They want a demonstration because this is a requirement for the moon mission for Artemis 3. The human landing system, they have to get to the moon. And they can't do that without transferring propellant in orbit. There's another minor issue, this concept of hot staging, where when you start at the second stage, the rockets are blasting out, and they do that while the first stage is still attached, and then they split. That way there's no pause in the upward momentum. And that turned out to be a great thing, but it was kind of a hack. What they did was they just stuck an extra section in there to protect the booster. You don't have this problem with normal rockets because nobody cares about the booster, but they care about the booster. They want to reuse it. So they put in this hot staging ring. But the thing is, Right now, they still don't really have all that much payload capacity, and it mattered. I mean, they decided they'd rather just get rid of that ring rather than try and have it come back with them. So they're just dropping it in the ocean, just like any other debris from any other rocket would have done. But at some point, they're going to merge that back in. There will be no more hot staging ring in the future at some point, and they have to test all that out. Now, as I said, the big question is really, what is the payload of this thing? It doesn't appear they have that much extra capacity right now, but there's a lot of improvements coming along the way that are going to change that. So that means more testing. In particular, the next versions of Starship, at some point, I'm not sure exactly which version, it's not this test, they will be taller, basically to hold more propellant and get a little extra payload that way. The big change will be the engine version. Raptor 2 is the name of the current engine. The Raptor 3 has a whole lot more power and it weighs a whole lot less. That's what they really need to achieve their 100 tons to payload kind of a goal, and probably more than that. There's some other issues that they've never really quite resolved. In one of the earlier tests, they did show opening a payload door. It wasn't that convincing that it was really working that well, but it wasn't really that important at that stage anyway, so they just kind of let it slide. At some point, they need to address that, partially because SpaceX really wants to launch Starlink satellites. They want to do that now with this new rocket because they have such bigger capacity. In particular, they can launch the version 2 Starlink satellites, which are a lot bigger and heavier than the existing ones. So they have a big economic incentive to get that going as soon as possible. There's a special dispenser. It's a payload thing. They call it the PEZ dispenser because it just kind of shoots the things out off the side. And they need to get that going, independent of the goals for the Artemis mission. They really have two different things here. There's their commercial interest, which is they need to get things launched as soon as they possibly can, either for revenue or for their own purposes for Starlink. And the other thing is meeting the needs for Artemis. And at some point, they're going to have to try catching the upper stage of the ship. Most people think that's a lot harder. There's tiles that are going to be damaged, that sort of thing. It's not quite as obvious how they're going to do that. Either they're going to have to work out some more details or maybe put legs on the thing and land. I mean, the earliest versions of Starship, which was just the second stage when they were calling it a hopper, they had legs. They've certainly done it before. They know how to do legs. At some point, reflying a booster. They haven't done that yet. Even this one, they caught the booster when it came back. Well, the next step would be, well, refurbish it is whatever you need to do and then launch it again. Like they're doing with Falcon 9, they're getting up to over 20 reuses with some of these now. They want to do the same thing with this. They really need that. Once they have that, the economics are so favorable. It costs so much more to build a rocket than it does to fuel it that the economics really drive you to go toward that. That's why the Falcon 9 has been so successful, and they need to do the same with Starship. At some point, reflying stage 2. They haven't done that yet. At some point, launching from Florida. They have facilities going up there. It's not as far along, but they do want to get that going. It will be needed fairly soon. If you're going to start doing a bunch of refueling missions, you want to have as many launch sites as you possibly can. And some of that's risky. If anything happens to one of those towers, you're pretty vulnerable. Okay, long duration mission, that's still an open question because even just while you're waiting for the ships to come up for your refueling mission, you've got to keep these fuels cold. I mean, you've got liquid oxygen and liquid methane. The easy approach is just let some boil off, and as it boils, that carries heat away. And then that's what happens if you have a Dewar flask or something on Earth with liquid nitrogen or oxygen in it. You know, that's how you keep it cool. It just basically is an insulated container, and it's not completely sealed, so some of it just vaporizes. But obviously that says you're losing material over time. If you're going to have to wait around 3 or 4 months or something between launches, you might lose a substantial portion. And if you lose too much, you know, you're never going to fill the thing up. So in 3 or 4 weeks, probably it's not too bad. For a long time, just because of the politics, no one was allowed to talk about orbiting fuel depots and that sort of thing. But now they are, and even United Launch Alliance, they're proposing making an orbital refueling system using the Vulcan. And they're doing the logical thing. They're saying, well, okay, let's put shades around it. Basically, you make a big metal cone that's a shade to keep the sun from hitting it. Right there, that cuts out a lot of evaporation, cooling evaporation is needed. That's not enough. The next thing would be put refrigeration equipment in there. It's cryogenic fuels. Well, we can do it on Earth. You can do it in space just as well. It's a little harder, but you can certainly do it. But it takes some energy to do that. It takes a lot of extra weight. So, there's a balance there of how much of that you want to do. But that's the kind of stuff they have to work out, because even in the case of going to the moon, it's quite possible that because of delays that happen now and then, you could have a ship sitting up there for, they're saying, 6 months sometimes, just waiting for the astronauts to show up. All it takes is one delay, and things get behind. And you need to start accounting for that. So at some point, they're probably going to be installing some equipment to do some refrigeration, maybe some kind of sunshade. It's going to be a big sunshade in the case of a Starship.
Sunshade is partially covered with solar panels.
Refrigeration isn't likely in near future testing. That would require compressors, which do take a lot of power. ULA has looked into a small generator burning the propellants, although that means you would still consume propellants. Doug suggested that the sunshade could be covered with solar cells to power the compressors needed for refrigeration. But either way, you'd also need a large area for radiators to remove the heat of compression.
You still have to radiate it into space, so you need big radiators as well. And then, it's much easier on Earth where you have convection and conduction to help you out. You don't have that in space. All you've got is radiation, so it's a lot tougher problem. So anyway, that's probably why they haven't addressed it yet. It wouldn't surprise me if there's people are thinking about it, because it is one of those things that's obviously coming. Okay, then of course, part of the contract that SpaceX has is to do an uncrewed lunar landing, meaning they have to go all the way and land, prove they can land on the moon. And that's not trivial either. It's a long way to go. It may be hard to find a level enough surface. How level does it have to be before the whole thing tips over? There's a lot of questions there that really have to be answered. So they really have a lot to do.
Doug suggested that we could send robotic bulldozers ahead of time to bulldoze a flat landing area to solve that landing problem. That would be a good task for the new generation of companies like Intuitive Machines that are making small lunar landers and rovers. Anyway, a lot of things have to come together for the Artemis lunar landing. What's going to hold things up? SpaceX and its lander, the Orion spacecraft heat shield, spacesuits?
The usual game in contracting, and it's not just government. I mean, I've seen other organizations do this, but you always hope that the other guy in the other division is going to be the one who makes the schedule slip. And so nobody wants to say, oh, I'm going to screw up the whole schedule. They don't say that any earlier than they have to.
That's all, folks. Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.